Osmosis, we've already talked about it. The whole thing with the egg is an example of facilitated diffusion. Okay? Surprising new research is to add water to the list of molecules that enter the cells by facilitated diffusion. Okay? And however, it says that many cells contain water channel proteins known as aquaporins. Okay, these channels, okay? See, like this? See, there's the channel again. But that's a special protein in the cell membrane layer. And it's designed only to allow water to pass through it. Okay? It's designed and it will only allow water molecules to pass through that channel. Nothing else gets in there. Sugar doesn't get in there, salts don't get in there, other proteins don't come through there. Only water can come through. That's how specific the protein channels can get. All right, and again, it's a very important part of that cell membrane layer. Those different proteins channels are real specific. Okay, so they keep things from getting into the cell that shouldn't get in there, and they allow things to get across that need to get in there. Okay? Osmosis is the diffusion of water through a selectively permeable membrane. Years and years and years ago, we used to call it semi-permeable. Now we call it selectively permeable because it selects specifically. In osmosis, as in other forms of diffusion, molecules move from an area of higher concentration to an area of lower concentration. The only difference is that molecules that move in the case of osmosis are water molecules. So water molecules are only osmosis. At this level, at the cellular level, it's the flow of water. It's strictly the flow of water moving across that membrane, getting into the cell, just like we did with the egg. Just like we did with the egg. It's the exact same process. Okay? But with the egg, we could actually see it, because when we took the egg out of the water after a couple of days, how much larger was it than the comparison egg, or the egg that we started with? Well, it was significantly larger. It had taken on a lot of water. Okay? Osmosis is the diffusion of water through a selectively permeable membrane. Okay? Okay, now, it said water will tend to move across the membrane until it reaches equilibrium. Okay, what do we say equilibrium is? That everything's balanced. It's got the same amount inside as we have outside the cell. Nature wants everything to be balanced. Okay? At that point, the concentrations of water and sugar will be the same on both sides of the membrane. When this happens, the two solutions will be isotonic. Isotonic means the same strength. Okay, so they're giving you, I said the same, they say the same strength. Okay, so it's got the same amount on both sides. It's isotonic. Okay? Strength refers to the amount of solute, not to the amount of water. When the experiment began, more concentrated sugar solution, right side tube, was hypertonic. Had lots and lots and lots of excess sugar on that side. Or above strength. We said too much. Okay? When compared to the left side, where there was a dilute sugar solution, hypotonic. Okay? Or below strength. We said not enough. Okay? So those three terms, isotonic, hypertonic, hypotonic. Okay, now here's what I was talking to you about up here. The effects of osmosis on cells. Okay, in an animal cell, and that's, they use a red blood cell, interestingly enough. Water goes in and out. Okay, if it's isotonic, the cell looks perfectly normal. Okay, that's the way a red blood cell should look. If it's hypertonic, okay, if it's taking too much water out, the cell, the red blood cell, starts to shrink, and it takes on kind of a star shape. It actually gets more star shaped like that than this. But you can see all these little puckered areas around here. Okay? And if it's a hypotonic solution, if there's too much water inside the cell blows up. Okay? And it can blow up to the point where the membrane bursts. Okay? That's how. Now that's in an animal cell, and that's a red blood cell that they use to show that. In a plant cell, it's a little bit different. Okay, because in a plant cell, you got to remember we have this organelle inside a plant cell called the vacuole, the central vacuole. And what's the vacuole do? It holds water, right? That's its only job. It holds water. But in an isotonic solution, it has the same amount of water pressure, or the same amount of water inside and outside, so it's equal. Okay? If this is isotonic, if this is hypertonic out here, it's sucking water out, and so that vacuole, it gives up some of its water, and it gets sucked out, and the plant starts to wilt. Okay? Or if there's too much water and the vacuole swells, okay, the plant can look green and leafy and may even look a little swollen itself. Okay? That's in plant cells. So those are the effects. Those are the effects of osmosis on cells. Right? And then we talk about osmotic pressure. Well, osmotic pressure then is the net movement of water out or into the cell. Produces a force known as osmotic pressure. It's the amount of water pressure inside and outside the cell. Okay? So you've got and it's called osmotic pressure because it's driven by the concentration of the solutions. Right? It's osmotic pressure because it's driven by the concentrations of solutions. Good question here. What would happen if the cells of a saltwater plant, if the plant were placed in fresh water?
Would they be getting too much water? Because first of all, it's salt water, so it would be like an equal amount of water because the salt kind of like balances out the amount of water. But if you get fresh water, there's no salt to like balance out, so there's too much water and it like fills up. It's
the same problem that we had with our egg cell. Okay, when you took the egg cell and you put it into a hypertonic solution of water where you had nothing but water outside the cell, okay, they suck up too much water. And yes, the cells probably will die. Some of them may burst because they won't be able to hold, because they're not used to having that much water. Even though they're in salt water, they're not used to having that much water inside their cells, so they would swell up, okay, because they take in too much water. Okay? Questions?